All right, 10.3 is all about evaluating expressions, which basically means figuring out the answer. Okay, that's all that means. So, 2c plus 5. He's using these cups and counters to model 2c, 2 cups, plus 5 chips. You don't know how many are in the cups. But you can see the 5. That's why that's the constant. So, what do the cups represent in this model that he's created? Okay. C is the variable we use, the letter we use to represent the cups. But what does it represent? What's in the cups? Some number of counters. We don't know how many counters.
How do we know there's counters in the cups?
Because we are trying to model an expression. What that means is there are counters in the cups. There may be no counters in the cups, but that's still modeling the expression. Okay, so we have 2 cups. Can there be 5 counters in one cup and 3 counters in the other cup?
Nope.
Why not? So you have 3 in one cup and 2 in the other cup.
You said 3 and 5.
Okay, 3 and 2 then. Can you have 3 counters in one cup and 2 counters in the other cup? No.
What?
2c plus 5.
5 more chips.
C
Is it C?
this number is going to be this number. So 2c is like saying c plus 5, right? How can c equal 2 here and c equal 3 there?
1 and 1, 2 cups, 3 copies.
It doesn't work that way. C has to equal the same number because it's c. C represents one number. If it was c plus b plus 5, there we have 2 different numbers. But here, it's the same number. So you cannot have 2 counters in one cup and 3 counters in the other cup. Not for this expression. They have to have the exact same number. So, what's my variable? C. What's my numerical coefficient? 2. Just the 2. What's my constant? 5. So, if C equals 2, if there are 2 counters in each cup, how many counters do I have in total?
4, 5.
Is it 4 or is it 9?
It's 9.
Why is it 9?
Because you have to add the 5.
Yes.
2 times 9. 2 times 2, and then it says plus 5.
2 cups, 5 counters. If there are 2 counters in each cup, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 counters. If C equals 2, 2C plus 5 equals 9.
Yeah.
It does, but that represents the number of counters in the cup. So the cups are the unknown. We use the cups to hide the counters.
Oh, I get it.
All right. C represents the unknown counters in the cup. They're hidden. Okay? So in this picture, what is this as an expression?
C plus 3. Alright.
Okay? Now let's put 6 counters in our cup.
You can't. Oh, wait. Wait.
Are we looking?
6 plus 3
Oh, C
equals
plus
9.
If we put 6 counters in our cup, what is the value for C?
6.
which means that 6 plus 3, how many counters do we have in total?
9.
Okay. What about if we take C here and look at this expression? What if there are 6 counters in each of these cups? How many counters do we have in total?
12, 17.
So if C equals 6, then 2C plus 5 equals 17, because 2 times 6 is 12, plus 5 equals 17. What's 2 times 6?
12.
Add 5 to that.
17. So in the cups, it's like.
What about if there are 10 counters in the cup? How many counters? I don't want you to answer. I want you to write this down. How many counters do you have in total?
Oh, wait. Are we doing the top one? Oh, okay.
My answer's here.
That's not the answer because you didn't multiply the C by 2.
What did I do?
You just went 10 plus 5 is 15. You have to do 2C, which is 2 times C, which is 20. And then you have to add 5, which is 25.
Yes, that was fine.
All right.
Equation.
Okay, new equation.
What does X represent?
3x plus 2.
What does X represent?
Does it matter? A number.
What number? What number? What integer do we represent?
Well, if x equals 3, what's the answer to this? Robin? Is that right? So what she's done is 3 times 3 plus 2 equals 11. What about if x equals 4? Yeah. Okay, how do you get the answer?
X equals 4, then it's 3 times 4 plus 2 equals 14.
Okay, what about if x equals 12?
Oh.
How do you figure out the answer?
That is 7. Oh, that was wrong. 3 times 3. Okay. Which equals 36. And 36 plus 2. 38. 38. Did I do that?
Okay. Take a look at this pattern of squares. Okay, figure 1. Figure 2, figure 3. This pattern can be described by 2n plus 1. What does n represent?
The one on the top? Oh, the n.
Yeah.
1 is 2 times 1 plus 1 is 3.
Okay. So the n represents the figure number. Okay? So n represents the figure number. So we're going to make a table of values. The figure number on one side, the number of squares on the other. Where the figure number equals 1, how many squares are there?
3.
For figure number 2, how many squares are there?
5.
for figure number 3, how many squares are there? Okay. For figure number 30, how many squares are there?
No, wait. We can figure this out.
Yes.
70 because 3 times 3 is figure, if is a figure and number squares is 7. So all you do is times each one by 10. And then that'll.
You cannot multiply this by 10 and that by 10. Why can't you multiply this by 10 and that by 10?
So that'll be 370. And then it'll just have
No. 3 times 10 equals 30, absolutely. But that does not mean that this answer is 70.
Yeah.
What's this answer?
You do 30 times 2, which is 60, plus 1 is 61.
You use the equation 30 times 2 plus 1 equals 61. You can't just multiply this way. You have to actually pay attention to the equation because the equation shows the relationship between the figure number and the number of squares. Okay, line segments. The number of line segments that form the squares can be described with 3s plus 1, where s equals the number of squares. Make a table of values. I want you all to do this now for s and 3s plus 1.